And then with that, I'll just turn it over. I believe Jason is our first speaker, and I'll let them all introduce themselves. But thank you for being here, and yeah, over to you guys.
Thank you very much, Brooke. I am going to share my screen real quick. We've got several things we're going to be, or presenters today. My name is Jason Barris. I manage the product development teams here at Infragistics, and I'm just going to do a few slides, and then I'm going to hand it over to the super experts, Victor and Damian, who will be really teaching us about Angular Schematics. So very quick about Infragistics, if you're not aware of who we are. Last year was our 30th year anniversary, so we've been around the block a few times. We have a heavy focus on desktop app, UI toolkits, as well as modern web, like Angular. So Angular is a big piece of product for us, and we're really excited to always participate in ng-conf. And unfortunately, we couldn't be there live this year. We're really happy we're able to do this to just continue to talk to the community, because you guys are what make us tick and give us the motivation to continue to build awesome product. So this slide really talks about our material-based components. So we are unique in this space. We have a set of UI components and controls for Angular. They're material-based. It's called Ignite UI. That's what you're going to be learning about today. But everything we do with this product is really about enabling you as developers to deliver amazing experiences to your customers. So you want really rich user experience, all kinds of cool capabilities, but you want to be able to do it in an easy way. That's really what Ignite UI is all about. And throughout today's presentation, you're going to be learning how we use schematics to enable some of that in our product. In today's presenters, the two key guys are on the left and the right of the slides. You're going to see Victor and Damian there, and their Twitter handles. And then Steven is in the middle with the red aura around him. Steven is on the product marketing, product management side. If you have any questions, there's his email address. But Victor and Damian, you have their email addresses now, or their Twitter handles now. So please tweet to them. Use all of our contact information to continue the conversation even after the webinar. So we really want to continue to talk to you guys about what's going on. So with that, I am going to stop sharing. I want to thank everyone for joining. I'm going to pass it off to Victor, and he can introduce himself and Damian, and then we're going to talk about how we're going to solve all of your problems today with Angular Schematics. Thank you.
All right, cool. As we said, I'm Damian, and my partner today is Victor. We both work at Infragistics. Victor is a developer, I'm an architect, and we work at the team that handles quite a lot actually within the company. We do our own version of a CLI, and within that we also do Angular Schematics. And we've been doing this for a while, and it actually solved quite a bit of our problems. So we'd like to share a few things with you today, so maybe you can solve yours. And as we said in the title, it's gonna solve all your problems. Of course, that is as long as your problems are limited to solving world peace within the Angular community, or in all seriousness, we know what the pain points of everyone is. Like, imagine that fancy new project you want to start, and all the time you spend into configuring the structure, bringing in tools and packages you love, just to get to actually working on it. And then, what else? That shiny new library that you found, but it also comes with an instruction manual to get started, so that's no good. And then you also may be sharing some, I don't know, the deployment or building scripts with within your company or whatever else, and that's something that needs to keep being maintained all the time. And then the bane of us all really is, once you get that project started, it's usually left there because everyone is too afraid to do updates, right? And because they're afraid of breaking changes. And those are all things that we can help alleviate today. So I'll actually defer to a quote from Scott Hanselman because it has stuck with me for years. And it's actually about a completely unrelated package called Edge.js, shout out. But it fits so well that I just couldn't resist using it. And it goes like this. So whatever problem you have, if you have this problem, this solves it. And I see Jason laughing. Thank you. That should have been audible. Right. So yeah. And since we have quite a bit of information to share with you today, we sort of want to whet your appetite first with some of the things you can accomplish with schematics. We're going to show off a little bit, of course. Hello. But yeah, so I'm going to turn over to Victor. He's got some demo for you. And I guess it should stop sharing.
It's sharing. Can you see my screen?
Yep.
Okay, thanks, Damien, for the introduction. So basically what I'm going to show you is how you can add the grid that Damien showed, like this grid, to your existing blank Angular project. So what we have here is just a standard Angular project. Just the output from ng new blank. As you can see, you have your app module, your routing module, and what we've done is just extract all of the stuff that comes with the app component template into a home component.
I think you might have a ghost directory in there.
I might, yeah.
Yeah,
you're right.
That is a ghost there.
Yeah, that was a ghost. So yeah, we'll show you how to add this grid to this blank project by doing a simple command like ng-add ignite UI Angular. This is a schematic CLI command, so is an Angular CLI command, sorry, which adds the package to your project. Sorry if it's a bit slow, I'll talk over it. And executes any logic that you might have attached to that hook, so to say. So this is done via schematics, and during our presentation we'll touch on this and show you how you can do it for your own libraries. What it's doing now is basically installing npm packages, so it has access to all the extra logic that we've put in them. It's taken a while. So you have this prompt here right now. You're seeing it's from schematics. It's a prompt if you would like to include some polyfills to support all browsers. So yeah, sure, we'll go with it. And if you'd like to include a CSS library that normalizes your containers, sure, why not? And as you can see, it includes some packages, which are just standard dependencies for our library. And it also says that the base library is installed, and now it's installing our schematics package. So you have access to commands that can allow you to quickly add these beautiful grid views or any other views for that matter.
Hey, Victor, can I interrupt really quick?
Yeah,
We're just getting some requests that you increase the size of your code. Can you make it a little bit bigger?
Okay. I mean,
perfect.
How about now?
Yeah, I think that'll help. Thank you.
Yeah, and I think too, Victor, since you and Damian are going to be using the command line a lot, you increase the size of that font as well if you can.
I mean, this is the only thing that we're going to be doing, so I think.
Cool.
Oops. So yeah, as you can see the changes, it's added it added some packages. It added the browser animations module to the app module. All this is done like behind the scenes, so the user doesn't have to do it themselves. We need this browser animations module in order for our grids to run and to have those smooth animations. The polyfills are added, and all of this is done behind the scenes without needing the user to actually input anything. So we offload a big part of this onboarding process off of them. And adding the grid itself, we've also installed our schematic package, which allows us to run this command. So
actually, Victor, can you actually bump up the font on the console?
Not sure
I know, it's not the greatest experience
really
ever.
Yeah, I guess. The font, so 24. Can you see this?
Much better. Thank you.
Okay, thanks. So we just run this schematic with ng. This is our schematic collection, and this is our schematic name, which is C, short for component. And as you can see, this prompts us with a menu, which allows us to choose from several components, so grids, like menus, gauges, scheduling, different charts, or even more fancier scenarios like the one that was shown in the presentation, this grid. Like it prompts us for a name, and then we can just cycle through this again. This is also handled by the schematic logic, or partly by the schematic logic, or we could choose to finish this and run start. And it's installing some other packages, since these are also offloaded from the start, so they can save time. And to save even more time, I have this project running on another port. And as you can see, this is the result. This will be the result in the other project as well. You have a grid where you can display a chart for selected roles. If you select other roles, this chart changes. You have all sort of functionality like grouping, sorting, filtering. You can click on a single row to display a chart by region. And we even have a little service that simulates a live data feed. So as you can see, the little numbers change. And what we hope during the presentation is that we'll be able to show you how to incorporate some similar logic in your own library, so you can ease the use of your users and save yourself some headaches. So ideally, what we want to go through is a quick intro of what schematics are, and then just jump right into it. So how you can create your own schematics from scratch, explain a bit about the API, go over an example which will create a schematic very similar to this one. So creating a component from scratch and adding it to an existing Angular project. And finally, we'll touch on these custom Angular CLI hooks, so ng-new, ng-add, and ng-update. And also Damien will take a deep dive into the TypeScript API, so you can save yourself even more headaches when updating files and touching stuff in the file system. So a quick intro to schematics. What are schematics? Well, they're basically the building blocks of the Angular CLI. You use them constantly, even if you don't know it. So like calling ng-gc or ng-new is actually calling a schematic. They work by making transformation to an in-memory representation of the file system called a tree. So this abstraction is basically used because it allows for better performance and actually doing stuff to the representation without reflecting it on your physical files. So you can do the so-called dry run, and it allows for advanced handling of merges. So like if you have a couple of incoming changes to the same file, you can sort those out. All of this is done by rules, which are highly reusable functions. These can also be tested by themselves, so that's really great because it provides a sort of modularity, and they also can be chained. It's a pretty vast API, which we'll touch on for going forward. And last but not least, there's the schematics provide a collection where you can expose schematics to your package's users, or you can keep some for internal use, which further ensures modularity and testability. And here, as you can see, are some of the schematics we each run daily, and I think most of us have seen them. So let's jump into ordering how we can create our own schematic. The Angular team have provided us with a really easy way to get started. There's a framework agnostic CLI that lets you create and run schematics. So all you have to do to get started on your own machine is run npm install this package, and afterwards just call schematic blank, and this will create a blank schematic. After the schematic is created, you can go in. If you check the files, it would look just like a standard npm package with a couple of exceptions. First, you notice in the package JSON, there's a property called schematics, which points to your collection. The collection is the place where all of your schematics are exposed to the users of your package. And in the collection, for each schematic, you have a pointer to an index.ts file, which exposes the schematic factory. And that's about it. Here you can see a quick snippet. So this is the property you find in your package JSON, which will point to this, which is the body of the collection, the schematic collection. The interesting thing here is, like the main point of interest, sorry, is the schematics property, which contains the definition of all of your schematics. So their names will have to be unique, so they can be differentiated by apps using them. And they have a short description and a factory. The factory points to a function in the file, like in that index.ts file we mentioned. And for our particular example schematic, this would be the factory. It's a simple function that takes in an object, an options object, which specifies the arguments that the rule will take into account when running. So if you want to pass anything, pass it through this object, and then the factory returns a rule which will be executed on the tree. The rule itself has access to the tree, so that abstraction of the file system, and the context. The context has a lot of useful stuff. We'll touch on that later. And this example schematic just logs a quick message. Now let's talk more about the API. So what you can do with the schematics, they expose a vast API, which allows you to do all sorts of stuff, including but not limited to manipulating files and doing all sort of creation, update, deletion to things in the file systems or directories. Through the context, you can log messages, as we saw in the example schematic, or chain different tasks. So you can chain npm package installs, or Git tasks, or even chain other schematics, which we'll do in an example. And last but not least, it allows you to chain rules. So operations on the file, on the tree, can be chained inside of the body of a schematic. And also, yeah, merge tree states, which we talked about earlier, and we'll touch more later. To better illustrate this, we'll go through an example scenario where we'll create two schematics and call them in a third separate one. One of our schematics will log a message, pretty basic. Our second one will create a file using the tree API. And our third one will just chain them using this context API to create the tasks. And this is the expected output we can see. Like, we'll expect to see a message and a print in the console that our file was created. So this would be our packet or collection JSON, sorry. It would hold the definition of both the schematics. So the config schematic will be one that create the files. Our greeter will be the one that displays the message, and our combine will be the one that combines both. How we'll do this is, for the config schematic, the first one, we'll be using the tree API to create files. As you can see, we can check for existence of files, so we can read the package JSON if it exists. If it doesn't, throw an error. From the package JSON, once we've read it, we can take the content and write the content in another file. Like, we can take the name of the, we can take the name of the package from the package JSON and write it in another file. So like a config file of sorts, using a simple JSON stringify. And all of this is done through the tree API. From the context API, we'll be taking advantage of the exposed logger, which gives us the opportunity to log messages like info or error messages if you want to stress out your users, or warnings. we simply just call context.logger and yeah, info or error or warning, and it logs a message in the console. And we'll also be using it to execute tasks. As said, there's a robust API that allows you to chain tasks, define and chain tasks, sorry. And we'll be using this one, run schematic tasks, which runs a schematic from the current collection. We have the greeter and config tasks already configured in the collection. And finally, we have the options object, which we can pass to the schematics running. We'll just pass nothing because they don't care about the options, these two in particular. And afterwards, we just chain them by doing context add task, the task predefined. And for the second one, we do content add task, the task predefined. And this here, the second argument is an array with IDs to which, for which this task is dependent. So it should wait for those. And if this is executed, finally, it would execute as in an order. Next, we'll go over a quick example of how to create your component, a similar component schematic to the one we showed, which would also expand upon the Schematics API, which we're currently going over. So what we'd like to do is create a component example that adds a custom component to an existing Angular project. By adding the component, we mean similar as ng-gc, so creates the component files and adds the component to the app module. But we want to further expand on that and create not just a component where the blank P works as the blank ng-gc components are. We'd want to template the input and be able to pass a name for it and a type. So to do this, we'll take advantage of the following. We'll strictly type the input for the schematic itself. So it would be able to accept two parameters, so the name and the type. Since we'll be doing a lot of stuff that we want to do, a lot of stuff that the Angular's ng-gc does, we'll call it internally and then build upon it. And finally, we'll use a templating API exposed by the schematics, which would allow us to change the files, sorry, of the created ng-gc component and build on top of them. So we can change what is visualized. This is what we want to input in our command line, and the output we want to be files. So I'll show you how it's done, like in action, I guess.
Or more like with preparation, because we sort of pre-done it, but hey.
We'll go over how it's done. So yeah, this is a simple schematics project. As you can see, we have the collection JSON. This is the basic schematic we showed, the one with the logger. This is our component schematic. As you can see, you have a description. It creates a component, pretty simple. A factory, which points to this index TS, and a schema, which is the new thing. With the schema, you can control what arguments your schematic accepts. So if we go to this,
you need to still zoom in a little bit, because the other Visual Studio zoomed in, but this one didn't.
This points to this schema, and this schema defines like what inputs the schematic accepts. So it's a normal JSON. The interesting property is this properties, which defines a collection of all the arguments you can pass to your schematic. So here we want two, name and type. As you can see, you can define a description for your property, a type, so string, boolean, number, and on prompt, which is interesting, if the property is not provided, you can prompt the user to enter something. So in this case, if it's a string, it will say, hey, please provide a name, and you have to type in a string. You can even provide a list. So if your property has an enum, it will only accept values of that list. So here the default is card, and what type of component would you like to add? So yeah, it will display a list where you can choose from, similar to our CLI that we showed in the beginning. Since this is TypeScript, we might as well type our options input into the factory. So yeah, we have a type and a name, both are string. And if we go into the component factory for the components, into the factory for the component schematic, we can see, yeah, it accepts options of type component. And then it tries to read your Angular JSON. If you don't have it, it throws, standard stuff. And it does all this to just get the source root. So app dash source.app. And you'd see it returns a chain of 2 executions. Now, what a chain does is do 2 rules in order on the work tree. So what we want to do here is, since we want to create a component, first we want to call the Angular component schematic, because it's already done. We believe it works. We know it's tested. So there's no need for us to reinvent the wheel when we can already use it. How we do this is by using the external schematic method, which is again provided by the API, specify the collection, which this is the collection with the default schematics exposed by Angular CLI. This is the name of the schematic, so component, and the options. We just want to pass options name. When we run this, this will create a component in our tree, just the same as running ng-conf name. The second thing, the second part is the more trickier part. Here, we're merging a source with the actual tree source. So what's a source? Well, it's the state of the tree, so to say. And how do we get the source? Well, we'll get it from our templates. So Angular's, the schematic actually API exposes a great range of functions which you can use to template your files. So we can just write these as a string here, but it will quickly get out of hand in terms of manageability. So what we're going to do is create our own templates. So under the component file, where we'll define our schematic as well, we'll put a folder with files and files per type. Since we only have card, it's only card here. And in it, we'll define our templates like this. So if you can see the names, you can see that they're a bit odd. So, and the template itself, it's not all that different from a component TS file, so a TypeScript file, but you can see all of these things that are kind of out of place. Well, that's where the templating comes in. These brackets and % mean start evaluating an expression. This dasherized name and here classify name are actually expressions that are going to be evaluated. And this means stop evaluating. For the path of the file itself, these are done with double underscore. And if you want to call a method, you won't use brackets like in the template, but you use @ So name @ dasherized, kind of like a pipe in your Angular component template, but instead of a line, you use @ and all of the files have a .template in the end. Don't worry about that. This is actually pretty convenient because if you have a .ts file which needs to be templated, you don't have to actually write custom rules for your TS config to skip over it. It will just skip over it, and the schematics templating API takes care of this. So the way we call this is take all of these files back in our schematics body, take all of these files and apply templates on them. So apply templating on them is basically called with a simple dictionary object where we have definitions for these dasherize and classify method functions, which you saw in the template. Well, they're actually pretty standard, exposed by the Schematics API as well. Classify turns a string into a class name, so camel case with first letter being uppercase, and dash rise does capital case. Yeah. And the name is the name we want for our component. So all of these will be evaluated in the templates. And afterwards, we just want to move these because the source is currently starting from here. We want to move these to the default app root, which we get here. So source dash app. And finally, in the chain, what this will do is apply this source. So the changes we want to do on the files with the current state. So the state where it already has the Angular component spit out. And we'll use merge strategy override because those are two sets of changes and we want the latest to come in. So these. And we can quickly build this by running npm run build. I'll just run the build and I'll switch to the more zoomed in. Yeah, we don't need this anymore. So if we go into another blank project, this is just a project where I dump these. We can call the schematic by doing ng, similar to the first time, but this time we'll pass relative URL to the collection JSON. So ng-gc, intro schematic, source, collection JSON, and the name of the schematic, so component. And if everything's correct, this should run. Yeah, see, the prompt we put in for the name is now prompted because we didn't input any name. So our name can be cool card or something. And it prompts us with a list of types of components to choose. We only have a card, so I guess we'll choose a card. And as you can see, it inputs that these components are all added to the existing project. If we look into the project in Visual Studio Code, I don't have a Git repository. Oh, I do. It's just slow. If we check here, you can see that all of these parts in the templates, which we wanted to be evaluated, are properly displayed here. So you have app cool card instead of app dash rise name, and cool card for the component name. So I hope this was helpful. And I'll be turning over to Damien. Just as a reminder, you could, if you're liking the seminar, or I don't know, if you're hating it, you can tweet at us on Twitter with @Infragistics and @ng-conf for a chance to win a one-year subscription to Ignite UI for Angular and do all sorts of cool stuff with schematics and our packages. So Damien, back to you.
I think it's universal that everyone loves it so far. So that's the feeling I'm getting. That's trending on Twitter, so it's great.
Oh yeah, keep up the Twitter chat as well. Right. All right. So I hope that showed you a basic glimpse into the schematics and what you can do. And so far we've talked about mostly general purpose schematics, something you can generate or something you can automate, either using the reference schematic CLI or ng-generate command. But if you want to go further, there's some points specific to the Angular CLI that you can plug into, and that's really where the fun starts. So, of course, you all know ng command, that's how we all start, right? But the thing is, you can create a schematic that handles ng, and that will be run when creating a new project. Of course, the way to tell the ng command to handle creation with your schematic instead of what it usually does is by overriding the collection entirely, which is instead, rather than the semicolon thing, is actually done through a separate parameter you have to pass in, but that's fine. And of course, you can already imagine what this can do, right? So say you already add 2 libraries when you start a new project, or you, well, for example, you want RxJS stores, or you want your setup to be just so in terms of structure. This will let you do that every single time you make a fresh project. It can be tailored to your custom needs. So the way to set it up is, surprise, surprise, you add a new entry to the schematics collection, except this time the name cannot be of your own choosing. It has to be named ng-new, because that is the way ng-new command looks through your schematics collection. And again, below is a simple example of how to call that. ng-new, you pass in your collection. In this case, it's the same as the interschematic project, but it can be anything else, your own library. And then you call it. But, and with great power, and you know how that one goes, you are really on your own after this point. Because once you override the collection on ng-new, it will run your schematic only with the options you specify. So anything you need created for the project structure, you have to do yourself, even something as benign as package.json or gitignore file. That's all on you now. And thankfully, because this is a schematic just like any other, you can go ahead and reuse these schematics that Angular has by default using their collection. So yeah, you can do that and then build on top of it. Or you can do something completely custom. That's entirely up to you. Then we have two commands that go hand in hand quite often. That's ng-add and ng-update and the hooks for those. And they are more geared towards libraries and their support their lifecycle. And the first one, ng-add, runs when you install a library in a project. And then ng-update runs when you install a newer version of that library in a project, right? And if that sounds an awful lot like a simple post install hook, we hear you, but there's a significant distinction here. This is better. And let me tell you why. I don't know about you guys, but when I install a package, I don't particularly expect a post install script to go ahead and touch any of my project source or spam my logs for that matter, but that's a different story, right? But when I run ng-add or ng-update, I don't only expect, I'm not surprised by this. I'm actually counting on it. I'm expecting it. I need this. There's a clear communication of intent when somebody calls ng-add. They want your schematic to run for their project. They're asking for you to set it up, or they're asking you to make changes to make their project work even after the update, right? And as long as everyone knows about ng-add and ng-update and uses them, it creates a great ecosystem that you can make better, at least for your users. You can ease their setup, their onboarding, and the pains they might face while updating. Okay, so a little bit of detail. How to set up your library or package with hooks for ng-add. No surprise there, it's again a schematic. It will run when you go ng-add, just like we did at the start with ng-add ignite UI Angular. It will be run when your package is installed in a project. And again, this is something that can make onboarding for new users extremely easy, because you can do all the configuration just like we did, install additional packages, make config changes, set up styling, set up everything for them so they would not have to do it themselves. Again, nothing too surprising. A new entry in the schematics collection. Again, the name cannot be of your own choosing. It has to be ng-add, except this time you don't even need to hustle with the collection at all, because ng-add is already called with your specific library in the name, so we don't have to do anything else. And then, of course, come the migrations. So you've made your shiny, awesome library, and then you made it easy for users to adopt it using ng-add, and they're happy now, and you have a bunch of happy users that report some issues, or maybe they log feature requests for some great features. And then you start implementing those and you realize, well, the things I made in the first version, those will have to change a little bit, like my public API or some configuration my library needs. Those will need to change for the new version to support those new great features. And then I know it's our favorite pastime reading endless changelogs, but users are not really like that. Most of us would just rather get it ready and not do too much and not face any breaking changes at all, if possible, and then just go to work. So when we say migrations, there's a certain distinction. So why is that? Well, don't you worry, they're still schematics, but they're special in a sense because they're configured just a little bit differently, like from everything else you do with your schematics collection. So the way you call these is similar to ng-add. You go ng-update and then your library name, and then you can also specify a version. It's basically like npm install yarn-add, kind of like that. ng-add is kind of the same as well, but again, different purpose and intent communicated through using those. So again, those are extremely useful for both you and the people that are using your schematics or library. So we make use of those extensively for one main reason: confidence. It gives us the confidence as developers and vendors for a library such as Ignite for Angular to make changes when we have to, because we can migrate those. And it also gives our users the confidence to run the next update and grab the shiny features, because they should not be worried that their project's gonna break if they get the new version, because we'll handle that for them, right? So you can imagine how useful that would be. Okay, so this is gonna be a little bit different this time because migrations are actually laser focused on their own thing. And since you're expected to have an ever growing number of them, they actually live in a separate collection. Although similarly, you still use a property in your package JSON to point to that collection. And the major difference for those schematics is they each come with a version that specifies at which point should ng-update in the Angular CLI will run which schematic or schematics, because it can do multiples. We'll talk about that in a second. So here's an example of a package JSON snippet that has an ng-update property that points to the migration collection. And ng-update is a property because there are some additional configurations you can add to updates, but we're not gonna dive into those too much right now. And similarly to schematics collection, your migrations collection also has schematics, except this time the name you give each schematics entry, such as migration 1 right here, doesn't play much of a role at all outside of testing maybe. What does play a major role is the version. So now you can see this is designated as version 2.0. So this will allow your users using the first version of your awesome library to update to version 2, and this schematic will be run when they update to version 2, and you can apply any changes you deem fit for their project to stay functional. And what's great is once you inevitably reach to version 3 and you still have to make changes as per usual, you can define yet another migration in this collection and it'll be stamped as version 3.0, right? And actually the great thing is Angular CLI is smart enough to figure out if some user is actually still running version 1, if they're updating to the latest version, and those migrations are incremental, and it will actually go on and run both the migrations for version 2 and version 3 once they jump through the hoop. So it will ensure that all your changes, no matter what version in between the user is updating from, will be executed. And this is a quick tip from us. So if you're anything like us and you have a whole bunch of migrations, then they just keep piling up since we keep releasing versions, and you have more than one team working on your library, or you accept open source contributions, do yourself a favor. Make that migration logic reusable and configurable through something simple, like for example, this JSON. That's our version of it. but I've seen it implemented in other libraries. And that's something I highly recommend to do, because you spare anyone else that is not you, that you have written those migrations, you spare them the need to actually understand schematics and migrations in detail to get something running. All right. Fine. So at this point, I'm hoping you have an idea of what you can do with schematics, and you have a bunch of things that you want to do, and they're coming up, and it's a list. And once you start implementing functionality, you quickly come to the realization that you don't want to just generate files or overwrite generated content, the whole thing. You actually want to go into the source and make precision, fine little tweaks on tunes and make changes in the source. And sure, you can probably get away with string hunting and markup, and you can probably get pretty precise and safe with that. But trust me, when you go and touch the TypeScript files logic, it's very hard to tell if you're actually editing the correct thing at the correct place. So we don't really we don't particularly like breaking projects. So that's where TypeScript comes to the rescue. Now, we normally associate TypeScript with the compiler it comes with, and that's what everybody's using. But what you can do is actually tap into that compiler's API, which will allow you to parse that string source file, gain insight on the source code itself, and that will hopefully allow you to make corrections in the code with surgical precision. And TypeScript being TypeScript, of course, you have interfaces for the core construct, such as a program or source files within it. And crucially, a source file is also the root of a syntax tree that is basically a representation of the entire source code. You can traverse that tree. You gain access to each and every single node. You gain information about that node. So you can touch on imports. You can see what the import is about, where it's from, what it's importing, variables, their types. Basically, all the things the TypeScript compiler knows, you can know as well. And this snippet below is actually an example taken straight out of our migrations utils, I believe. So once you parse a source string into a source file, you can, for example, go over the top level statements, which include imports and class definitions, or for example, filter those out looking for import declaration. This is something that we do, for example, when migrating rename changes, and I'm going to talk about that a lot, I guess. But this is something that we do when we hunt down for an import from our own package, so we don't touch anything that we're not supposed to touch, of course. And we're looking for some imports that we have to rename or otherwise track further down in the code and manipulate. So, of course, the syntax tree doesn't only give you access and knowledge on the source code, you can also manipulate it. So you can go ahead and create new nodes. Everything in the source tree is a node. So you can create new nodes, manipulate existing nodes, or read and create new stuff. So for example, you can create a new import declaration, or you can go ahead and touch on decorators, the class decorators, which would be the component and ng module decorators, which we do constantly. And now I know data is the best currency, and the compiler API will give you the data, but you have to do something with that data that matters. That's what counts. So one option to go ahead and do that would be to use something that builds on top of it, and that would be the TypeScript language service. And that will give you the smarts to your data, if you will. So it's about as powerful as it gets, although I'm guessing there's a package out there that's probably even more feature rich, but hey, that one's right there. So what you can do with the language service, I'm gonna give you just a quick example because I'll stick with the renaming theme. So for example, you can trace definitions or references just to a variable or instance, or find the rename locations for anything that you pointed to, which is basically like F12 and F2 commands in VS Code, right? And that's no coincidence, because the language service will give you just about anything you can imagine in terms of functionality, although it is a lot, definitely. So you can trace a variable or a class back to its definition. You can navigate code between matching braces if you want to single out a single block. You can even check for errors after you've changed something, or ask for code corrections, or go even wild and do refactors. And if all that sounds familiar, that's because the language service is basically what drives your favorite development environment, like VS Code. So anything you can imagine in terms of feature, you'll probably find it as a method of a service. And now, of course, it wouldn't be that such additional power would not come without a cost, right? So a language service in TypeScript requires a host to run, which is basically its middleware to talk to your source code. And that would normally just read off of the file system. But since we're running with schematics, and those run with a virtual file system tree, just like the one in there, we'll have to do something a little bit special. So when setting up a language service host, the main methods that we should be interested in is getting a snapshot, which is the service's way to read your files. And what you can do is bind that host to your virtual tree and use its API to return snapshots for the service. And here's the catch though. The method does exactly what it says on the tin. It is a snapshot, and the service does cache. So the way to tell it to invalidate that cache is normally giving it a script version. Now there's a slight problem with that, since the Schematics virtual tree API doesn't really provide, at least not publicly, there is no timestamp on changes, and there's no versioning built in. So what we end up doing is version it ourselves. And I know this might not be the way that everyone would go for that, but that's how we did it. We just made a map for every file we have to change and increment versions per change. And how we detect those changes is basically by doing a monkey patch on the tree override method. So we know every time that is called. That is our way of doing it. Your mileage may vary. If you have a decent idea where your changes are, you might not have to go there, but I just had to mention it. So you've dug through your source code and you've got a good idea what changes you want to make. So now, how do you go about actually applying those changes back in the tree? So there are two ways to go about it, depending on the scale of changes you want to make. So you can do string manipulation, because if you just want to replace a single node's text, it already has a start and end index that you can find in the syntax tree. Or if you've used the language service and requested rename locations, those will also map nicely back to the string source, and you can do that as well. But if you really want to go fancy with it, you can just go ahead and redo the entire syntax tree yourself. Apply changes, create new nodes, edit nodes, do whatever. TypeScript is nice enough to actually include a printer, which is basically like a reverse compilation, if you will, because out of the syntax tree, it will not output JavaScript, it will actually output TypeScript back, which is awesome. There's, again, a small caveat with that, and that is the printer it does have some options to configure, but they're not a lot, and it's a little bit opinionated in terms of formatting. So it will basically do double quotes and tap indentation, no questions asked. But again, this is something that we do all the time. The language service, pretty much again to the rescue, it does have a functionality to allow you to do file formatting. So if you want, you can ask the language service with options, including indentation and quotations. You can ask the language service, hey, I want this file formatted to these specifications. Give me the places I should edit, and you can reformat that file just the way you like it. So I guess that's sort of it. it's more of, we're basically just touching on the surface here. There's so much more you can do because schematics are just like your package and your code. You can bring any other tool you seem fit. We just stuck with what's available out of the box, but you can build on top of that as much as you like. And it's a great way to ease the process of getting new users and keeping them, and perhaps making them happy. And so I'm sure that that would free up some time for you to solve all the other problems you might have. All right, so I guess that's it. And we'll leave you with a whole bunch of resources for documentation, for schematics, for TypeScript compiler. The demo Victor showed is also on GitHub. We'll point out everything that we talked about. We have an implementation in one package or another. We have a bunch of them, unfortunately, but do ask, we'll point you to the right direction. We'll leave you a bunch of links, and then we also have some tutorials and blogs from our Infragistics site for you. So go ahead and check those out. You will get access to the slides. I saw that in the chat. I believe we'll send that out at some point. I'm guessing the answer is yes.
Yeah, so we've been recording this whole thing, and we'll have it edited, just kind of made pretty. And then in, I don't know, about a week or so, we'll be able to publish it on the ng-conf YouTube channel. And then if Infragistics would like to do that as well, they can. But yeah, we'll make this whole thing available.
We'll make the slides available, and yeah.
Yeah, if you get us the link to the slides and things, we'll make that available as well.
All right. Well, in that case, we're sort of open for questions.
Yeah, so if you want to go into the Q&A down there, Damien, you can find the questions, and then we can just start at the top and work our way down.
Okay. So the advantage of learning schematics vs creating a abstract syntax tree project using TSMorph. I don't get what the project would be, but if you want to use TSMorph, I say go ahead. But so far, what we've been doing is using both, because schematics are just the delivery tool for your changes. You still have to figure out how to do the changes yourself. So go ahead and do both. Schematics are just the way that the ecosystem is set up right now. And it's sort of nice that we finally have an ecosystem where everything is known and expected. So at this point, when you start a project, you sort of expect to run ng-add, and you expect to run ng-update when a new version is there. That's the default now. That's the expectation for it. And that's great. So yeah, I guess I should click answer live.
Yeah.
All right.
Because I mean, it will probably mark it as answered.
Yeah, it just moves it into a different part of the Q&A.
Okay, okay.
Okay, guys, so I can read the second question. It's about when Victor created the, the custom schematic, where there is two parameters like name, which was my card, and again type, which was card. So the question is, can we validate those parameters, the name and the type?
Thank you. I know there are a few methods, but they're built in. There is an...
You mean through the schema?
Oh yeah, you can define in the schema, you can define patterns for the names, but they were like an HTML tag and something else.
They're limited.
They're limited, and they're not really too well documented. You can probably dig those up from we do this all the time. You can go into Angular Dev Kits packages, and you can check out how they use it. I'm fairly certain ng-new, for example, uses, for the new project name, it uses a HTML-like validation, since you can only input words and a dash. But yeah, I don't think you can do like full regex patterns explosion thing. Although you can always, once you get that input in your schematic code, you can always validate that again and throw an error if it doesn't work for you.
I only
Read
can
out loud if you can.
I can only add to the previous one that as Victor showed, there is a prompt, and you can always use the prompt instead of, you know.
Oh yeah, if you have
with
specific
predefined,
options.
yeah.
Yeah, if it's a list, it's easy. If it's a pattern, it's trickier.
Right. So here's the deal. I'm going to expand on that just a little bit more, I guess. The schema you define for the schematic itself is sort of like the pre-run, if you will, since the CLI will gather your options before any bit of your own code actually runs. So that schema tells the Angular CLI or the Schematics CLI how to handle input. But once those options are generated based on that schema, if they pass validation or not, you can still validate them again because your code is run at much later point after you get the options already. Okay. I'm gonna read the next question. So you're a library author and you want to bootstrap an initial application.
It's pretty interesting.
Should the override for ng be added to the library or global separate package? Same with ng-add. It's not clear if users have to npm install the library first to get access to the schematics, or the ng binary knows how to download and run those. Okay. I guess it varies, but for ng-add, you definitely want to include it in your package or your main library, because like we do with ours, you do ng-add the library, like ng-add ignite to Angular. You don't want it to be ng-add some schematics package. It's just not as convenient. It doesn't really ring the same way or correspond to a normal install that you would do. So I guess the de facto for adds, at least the ng-add schematic, would be to keep it in your library. And that is something that we do. If you want to offload parts of the code that your ng-add has to do, you can install a different schematic and the separate schematics package. That's exactly what we did. Like Victor showed in the start, when you call ng-add, it actually added the library itself and the schematics package, because we actually need that schematics package to run one of its schematics for a setup. So you can divide and conquer, if you will. And for ng-new, I guess either way goes. We found we do way too many things.
I mean, don't you need the collection to be globally installed locally so you can run it?
Oh yeah, that's a whole different story. Yeah.
Yeah.
So that's a very good reason not to put it in your library, because you don't particularly need your library globally installed. So yeah, when you go ng-new -- collection, the collection you provide, it's either that relative thing that Victor did, but that was just for local runs, or
you're never doing that, basically.
Yeah, that's just local debugging, if you will. But what you normally do is give the package name. And if you give a package name, the Angular CLI would expect that to be found either inside the current project, and since that's ng-new, there is no current project, or installed globally. So yeah, I would definitely go with a separate package for ng-new. Plus, as we found out, we do way too many things with ng-new, and we also have a bunch of additional package dependencies to do that, and we don't want to carry that with the main library. So go with a separate. Can you modify? Okay, next question. Can we modify the HTML with schematics, like change the component selector from component 1 to component 2? Yes, that is exactly what migrations are for. That is exactly what we do with them. And yeah, you're gonna have to find your own way. There is no built-in API for that. You do it on your own terms. However you see fit. Yeah. There is no API built into the schematics. It only gives you access to the file itself. So in terms of migrations, any change you want to make, you do it on your own. You can find HTML parser packages are pretty common. We sort of forwent that because our migrations are, again, part of the main library. We didn't want to do anything extra, so we just did simple string searches. That works all right. Do you have a recommended library of functions that will apply updates to the AST, for example, add node import to file function? I wish I did. I believe everyone's doing it on their own. we certainly did because, again, additional dependencies, but I'm certain there must be something. If anyone else knows of such library, please chime in the chat. Thank you.
I think the next question is a follow-up to one of the answered ones. If you're marking this one as answered.
Oh yeah. Wait.
The next one was about I think migrations. If you can run a migration without actually only by doing ng update, or is there another way? Well, there is another way that you can run it like sort of like we showed the local thing for debugging purposes. You can do ngg, the path through a collection, and afterwards the name of your collection of your migration schematic. To expand on that, you can't actually tap into ng update in any other way because it checks in your what's the word, repository.
Oh, ng update does a whole lot more than that. It's actually one of the more complex commands within the Angular CLI because it will go check against the npm registry.
Yeah, registry.
Oh yeah, it will go check your project. It will find all the stuff from the npm registry. It'll check which projects have migrations defined and what versions are for those, and it will offer you the chance to ng update whatever package you want. But that all happens. So it has to be able to talk with the registry. So ng update is kind of the way to go.
Yeah, but yeah.
Did you mention that since migrations are still schematics, you can run them? Except
yeah,
it's
that's
not.
what I did.
Oh yeah, okay. Sorry.
I mean, if not installing, you can run them with ngg, but there's not another way to run them.
Yeah.
I mean, those are just the two ways. You either have a newer version available in one of the registries, or you run them manually by ngg.
Oh yeah. For the record, anything that we said is a special type of schematic hook. So ng-add, ng-new, anything like that. They're still schematics. They're just triggered by an additional command that does something extra and looks for a specific schematic. But you can still point to your collection, whether that would be the schematics collection or the migration schematics collection, and you can call out by name anything you like with ngg or schematics CLI, and it will run it.
There was a question if there is the opposite of ng update, if you want to downgrade a version using the migrations.
Oh boy,
you can.
There isn't, and I'm guessing that's on purpose. The intention is to go forward only.
Yeah, you need a different transform function for it. So like it progresses from one state to the other, but it's not necessarily the same function to bring it back. So it's most definitely not the same function.
Oh yeah, and
so
that's definitely not something handled. So
yeah,
the schematics don't really provide a way for that. And I'm guessing again that's intentional.
You can write your own schematic so for a backwards migration, and the user can run it, but you'd have to provide it. There's no way to automatically run it. So like ng degrade or something. For a folder or file in ng-new schematics when creating an initial project. Yes.
Yes, you can.
Create everything. Basically, it's up to your imagination, or what you want to do.
Right. That was in the demo Victor showed in VS Code when you had a URL source that's created off of a file within the schematic of a folder of files. within the schematic itself, you can do the exact same thing with ng. No problem.
You just have to include like the files you want to include in the package that exposes the collection. You have to ship them.
You ship them with the schematic. The schematic can create a source from them and then merge it within anything else. How would one go about modifying files written in a different language like Rust? Oh, that's a good question. I'm sort of hoping Rust would have a similar API to go with it, but I'm really not sure.
So basically keep your fingers crossed.
Oh yeah, but again, schematics are just basically node projects or node modules. They're not special in sort of like, there is no restriction on what you can run, although don't go crazy, please, thank you. But still, you can call up any additional package. I sort of assume that there's a npm package that will handle Rust out there, so you can definitely bring that in and use it. Okay, so the question is, do you have any examples of gotchas, pain points, and anti-patterns that you've run across that we should be aware of? Well, I guess we sort of touched on some pain points. It's always tricky, especially when you're bringing up external functionality outside of the Schematics API, such as a TypeScript compiler, or I guess somebody mentioned tsmorph, and there are a few good TypeScript packages out there. It's kind of hard to teach them not to touch the file system directly. So that's a pain point, definitely. So we had our struggle with that, and we do everything we can to funnel every operation through the Schematics virtual file system, because that otherwise you would go, yeah, I'll do a dry run on this schematic, or for example, and somebody would go ahead and touch the file system, and that's not cool. That's not expected, right? Because a dry run would still run, and that would actually happen transparently for your code. Is it transparent? Like, your code would not know it's running in dry run. Your schematic will run just as expected, apply any changes to the tree just as expected, except when the time comes for those tree changes to be applied to the file system, the Angular CLI itself will say, oh, nope, that's a dry run. We're stopping here, right? So that's definitely one thing to avoid. So anything else you bring, make sure you go through the proper Schematics API for touching any files. And what else?
Or to expand on that, like we had a couple of issues with our template files. So where we read them from, because if you try to access them from the tree, you can't actually do it because they're actually not in the app root, they're in your package. So you have to do fs and read, and where in the tree you have to use tree, and it's a bit tricky. So you can get kind of what's the word, entangled there. So what we did in our implementation, like in one of the parts, we did a simple overlay of the state, so an abstraction. So we know whether we're touching actual physical files to, for instance, get our templates, or we're touching like the tree and the current project state. So we know we have to be careful, like Damien said.
Okay, I really can't think of anything else. I might later on. If I do, I'll make sure to mention it. But
yeah, I don't know.
I guess do describe your schema as well as possible, because Angular, the CLI will actually, when you go for collection that component --help, it'll actually output the contents of your schema as help. So do make sure you maintain that one.
Oh yeah, I didn't mention that.
Yeah, I'll figure out something else later on. You know, I might tweet it. Who knows? All right, I am marking this as done.
Okay, I think we got through them all. That was awesome. 17 questions answered, so great.
We apparently had little helpers running around where we were presenting. So that's really nice.
We try. We try.
Thank you.
We left the hard ones for you guys.
I would assume so.
We answered ones like, how's the weather?
Oh,
Is
That must have been a hard question to ask.
it
to answer,
Friday yet?
Because
Yeah.
how's the weather? How's the weather where?
Yeah, it's a global presentation.
How's the weather? It varies.
Yes.
Hey, well, any last thoughts, Jason, or anyone else?
Nope. Thank you everyone for attending. Follow us on Twitter and obviously ng-conf for the webinar replay. So we really appreciate your time. You have everyone's information here to answer questions and follow up. So back to you, Brooke.
Okay, perfect. Then yeah, we'll just we'll go ahead and choose a winner for the prize of that 1-year license to the Ignite UI, and we'll make sure to notify the winner that they have been selected. So that'll be great. And then also a really common question at the end of webinars is always, can we get the replay? Can we get the recording of this? And yes, we will make that available. So it usually takes about a week just to have everything edited down. But give us up to 2 weeks just in case whatever comes up. And we'll have the replay of this put up and available on our YouTube channel. And yeah, you can go back and watch it at your convenience. But other than that, again, just like Jason was saying, thank you so much for attending. We really appreciate your support and look forward to additional webinars coming up in the future. We have a lot slated, so those will be great as well. But thanks for attending, everybody, and we'll hope to see you around.
Thank you very much, Brooke.
You as well.
Thanks, guys. I'll see you. Bye-bye.
Thank you.
Bye.
Enjoy your evening.
Have a good one.
Yep. Bye-bye.
Have
Enjoy
a good day
your
on your
food.
side.
Lunchtime.
Really? Oh, cool.
1:30.
Dinner time, I guess.
Yeah, you guys are past dinner time.
Oh, wait. Yeah.
Depends. Second dinner time?
Is that a thing? Okay.
It is
I'll
now.
see you guys. Thanks.
Okay.
Bye-bye.
Thanks,
Bye-bye.
everyone.
Thank you very much. I appreciate it. Great job.
Going. Bye.